All right, so this is our last topic for analyzing limits analytically, and it's involving one-sided limits. So looking at from just the left or just the right given a function. So first off, let's go ahead and understand that our function in this case is a piecewise function, right? It's given to you here. We're looking at f of x is equal to 2x minus 1 if x is less than or equal to 1. And we're looking at that f of x is equal to 3x plus 1 if x is greater than 1. On your guided notes, there is a visual of what this graph looks like, but here I want to focus on the algebra involved in determining limits of this function. So first and foremost, it's important to understand that here we're looking at the limit as x approaches 1 from the left. Okay, and that's of f of x, right? And we're told that f of x is equal to that piecewise function of 2x minus 1 when x is less than or equal to 1, and 3x plus 1 when x is greater than 1. So we need to figure out, where is this idea of left in my domain? Okay, so where is left existing with these restrictions on x? I know that values that are to the left of 1 are values that are smaller than 1. So we want to go ahead and pick the domain and then the corresponding linear function that matches with that idea of values of x that are smaller than 1. So I see here in that first line that we have x is less than or equal to 1. That's corresponding with 2x minus 1. Okay, what that tells us to do, that tells us that we need to, in order to evaluate the limit as x approaches 1 from the left of from the left of positive 1 of f of x, we need to just use the component 2x minus 1. And what's nice here is we can actually just calculate that using direct substitution. We find that that is equal to 1. Okay, so what that means is that the limit as x approaches 1 from the left of f of x is equal to 1. Okay, so the next example, not surprisingly, is asking you what's happening as we approach 1 from the right. So what's the limit of f of x as x goes to 1 from the right? Okay, and again, you don't need to, but I'm going to, just for this example's sake, copy down my f of x again. It's 2x minus 1 when x is less than or equal to 1, and 3x plus 1 when x is greater than 1. So when I'm thinking about numbers to the right of 1, I know that I'm talking about numbers that are bigger than 1. So I'm going to use the equation 3x plus 1 in this question to answer this question. So that tells me that to calculate the limit as x approaches 1 from the right, I need to analyze the linear piece 3x plus 1. And I can see that there's no issue of that division by 0. There's no crazy square roots, so I can go ahead and try direct substitution. And I see that that is 3 times 1 plus 1, which equals 4. So this tells me that the limit as x approaches 1 from the right of f of x is equal to 4. And on your guided notes, you can see the graph of f of x, and you can go ahead and verify that, in fact, here in example 11, that when you're approaching x from the left of 1, you're getting a positive 1 value. And then you can verify that when you're approaching x is 1 from the right, your function is tending towards that value of 4. Okay, so next we're told to evaluate the limit as x goes to 1 of f of x. And we've actually done all of the work in order to answer this question. So something that I want to remind you guys of is the fact that a limit as x approaches some number c of some function exists. Is that how I spell exists? Nope. That looks wrong too. You guys can make fun of me at this point for my spelling issues. So the limit as x approaches c of f of x is equal to some value L, or exists, if the limit as x approaches c from the left of f of x is equal to the limit as x approaches c from the right of f of x. Okay, so translating that to what we're asked to evaluate here is saying that the limit as x approaches 1 of f of x, it exists if the limit as x approaches 1 from the left of f of x equals the limit as x approaches 1 from the right of f of x. Well, from example 12, we know that the limit as x approaches 1 from the left of f of x, we know that that is 1. And from example, or actually that was example 11, from example 12, we know that the limit as x approaches 1 from the right of f of x is 4. So since these values are not equal, we can say that the limit as x approaches 1 of f of x does not exist. Okay, our function is going to 2 different values as we approach the x value of 1 from either side. Okay, last example for these notes, we're asked to evaluate f of 1. I'm going to remind myself that f of x is this piecewise function, 2x minus 1 when x is less than or equal to 1, and 3x plus 1 when x is greater than 1. So what this question asks is actually for us to evaluate this function, right? We're asked to figure out what is f of x when x equals 1. So in order to do that, we need to figure out where is x equals 1 supported in our domain. So we can see x equals 1 is included in this first line. So at x equals 1, our function is behaving following the linear equation 2x plus 1. So in order to do this evaluation, we're going to take 1 and plug it in to the component 2x plus 1. So that will become 2 times 1, it's minus 1, sorry. 2 times 1 minus 1, which is equal to 2 minus 1, which is simply equal to 1. Notice because our domain restriction here does not include 1, we would not want to plug it into 3x plus 1. So this tells us that the value f of 1 is equal to 1. And you can go ahead and check out this information on the guided notes. You should see that there is a closed circle at the point 1, 1, and an open circle at the point 1, 4. So that tells us graphically that the output of f of x when x equals 1 is positive 1. Okay, just a few more practice problems for you guys to try. Make sure you're checking your work on the answer key in Google Classroom and reaching out to